All right, in the first part of this video, we went through the beginning of this problem. We read through, we found we identified our variables. We wrote an objective function. We're trying to minimize the cost. So this is the cost. And we wrote our constraints out based on each vitamin, the needs, and what the pills have. So now what we need to do is graph the constraints to get our feasible region. And then we're going to make a table of corner points and find the minimum cost based on that. Okay, so first, to graph the constraints here, I'm going to start with A there, line A. 8x plus 2y equals 16. I want to graph that line. And, you can kind of cover up the x there, let x equal 0 basically, and you get 2y equals 16, y equals 8. It's the intercept method. And so 0, 8 is a point on that line. I'm just going to put 8 here, put a point there. And by the same token, I can cover up the 2y, say y equals 0, 8x equals 16, and I get x equals 2. So that means 2, 0 is a point on that line as well. You can graph this however you like to graph lines. If you want to find the, solve for y and do slope-intercept form, that's fine. But this is a really quick way to get these lines. And the graphs don't have to be perfect. I just need to see them well enough to know which lines intersect where, so we can get our feasible region and kind of shade them. All right, the next equation is this B1. And we got x plus y is greater than or equal to 5. So I want x plus y equals 5. And you can solve for y, do y equals negative x plus 5, y-intercept 5, slope of negative 1. Or again, you can do the intercept method. If x equals 0, y equals 5. So 0, 5. If y equals 0, x equals 5. So 5, 0. So here's 5. Here's 5. And here are my points. There's my line. Okay, and the last one there, vitamin C. 2x plus 7y equals 20. If y equals 0, then x is going to be 10, right? 2x equals 20. So 10, plot that point. If x equals 0, then divide both sides by 7. Y equals 20 over 7, which sounds complicated, but 21 over 7 is 3, so 20 over 7 is just a little less than 3. So that should be right around there. And I don't need to write it in any particular way. I'm just going to call it 20 over 7 and graph my line. And all I really needed here, what needs to be correct is the relative placement. I'm sorry, I don't like this line. The relative place. Oh, geez, I'm struggling even more from that direction. There we go. Okay. The relative placement of these intersection points just needs to be correct. So I need to know if two lines intersect above or below another line. I'm 100% confident that I have these in the right place because of the way that they go, right? But if there was another line, let's say if I had another constraint, if it was coming through this way, for instance, right, I would need to know, is it going to the left or right of that point? And is it going to the left or right of that point? Because that could affect which corner points are, it would affect which intersections are actually corner points on the feasible region. So that's what you got to be careful of. But there's no ambiguity here. We know where these intersection points are. This line in red is line C. This line in pink is line B. So I'll label them that way. Or you can label them with the equations also. And as for the feasible region, it could be like in here or in here or in here or in here or out here. We need to figure out where it is. And so for that, we're looking at these inequalities. And all of these inequalities, they all have positive x and positive y, and they're all greater than a positive number. And so because of that, they all have positive y is greater than. All three of those. Positive y is greater than. So that means we're going to shade above all three of those lines. So with that in mind, you don't really have to do each one separately. We're just going to shade above all three. And also to the right of the y-axis and above the x-axis, because x and y both have to be greater than or equal to 0. So this is my region up here. And you know what? I'm going to redo this and use a thicker. This is my feasible region. I guess I didn't really need to make this that perfect, but all this is the feasible region. And so what I need is the corner points here, and the corner points are this point, this point, this point, and this point. They are part of the feasible region, right? And we're trying to find the minimum cost. If it was asking for maximum, there would be no maximum because these are both positive coefficients. So as x increases and as y increases, so does z increase. So going out this way, there would be no limit to how big z could get. But we're not asked for the maximum, we're asked for the minimum cost. We're trying to spend as little as possible on the vitamins. So yeah, like we want to go this way. And I don't know, is it this one, this one, this one, or this one? It really could be any of them at this point until we check them. So we're going to set up our table. And we're going to do x comma y with our corner points, and then z over here. And our corner points are just 0, 8, 0, 5. Whoops. I'm sorry, not 0, 5. What am I doing? 0, 8, 10, 0, right? This one. And then there's the two intersection points that we have to find. 10, 0. And then we're going to have two intersection points in here. They don't have to be in that order, whatever. Anyway, the two intersection points. This one is the intersection of A and B. So I'm going to do that really quick here. If you look at these two equations, well, they're inequalities, but we're going to write them as equations. I need to figure out where they intersect, right? So it's a system of equations, and you can do it however you like. You can do substitution, elimination. You can put them in a matrix and do reduced row echelon form. I'm just going to do this. I'm going to say equation A is 8x plus 2y equals 16. And then equation B, I'm going to do negative 2 times equation B, or B1, whatever. And I'll get negative 2x minus 2y equals negative 10, right? Just multiply everything by negative 2. Now I can add them together and I get a nice quick elimination. 6x equals 6 gives me x equals 1. And since B is one of those equations, that's an easy one to use. If x is 1, y is going to have to be 4 to make that true. So y equals 4. That's this intersection point right here, 1 comma 4. And so I will put that in my table here of corner points. And then the other corner point I want, the other intersection point I want is this one between B and C. So I can do like the same thing here, B and C, right? I'll use negative 2 times b again because that'll eliminate x for me. And so c is 2x plus 7y equals 20. And negative 2b is going to be negative 2x minus 2y equals negative 10. And so when I add those, I get 0, 5y, and 10 tells me that y equals 2. And again, in that equation B, if you look at that, x plus y equals 5. If y is 2, then x is definitely going to be 3. And so that is this point right here. This is, 3 comma 2. I was going to write 2 comma 3. It's 3 comma 2. And so those are my corner points. Notice I did not need this intersection point where A intersects C because it is not bordering, it's not part of the feasible region, right? The green doesn't come up to that. And so that's not feasible. That won't get all the vitamins that Mike May needs here. So that's why it's not in the feasible region. It didn't fulfill those constraints. So anyway, my Z was 0.15x plus 0.3y. And so 0.3y, 0.3 times 8 is 2.4. So 240, that's money, right? 1x is 0.15 plus 4 times 0.3 is going to be 1.2. What am I doing? 1.2. And that's going to be $1.35. Did I do that right? I think I did that right. Yeah. 3 and 2 is going to give me 45 cents on X and 60 cents on Y is $1.05. That's going to be the minimum. And if I plug 10 in, I get $1.50, 10 on X. And so that's it. I got my answer. It's this right here, right? This is the minimum for Z, $1.05. Those other corner points all get all the vitamins that are needed, but just not for as little money. So I will say Mike May, or maybe that's Mr. May to you, will spend the minimum $1.05 a day using 3 of brand X and 2 of brand Z. Nice complete answer. I'm going to make sure that you very clearly answer the question that was asked. All right, it's a word problem, word answer. I'm not big on complete sentences necessarily, but yes, complete thoughts are needed, and units and anything like that. Anyway, that's it.